Let me record and then try to sharing screen. Okay, I have one more coming. How do I admit? Okay. Needed to share screen. So today we will start with new topic. It's about is it hold on, okay, I needed to enable them join in. Hold on. They are waiting. Okay, now they still having, oh, hold on, okay. Admit all. I already admit. Okay, let us, we can start. So today we are going to start with a new unit. This new unit is about modeling. I should be able to write it. So it's about modeling, okay. Modeling. And the modeling, and we are not going to go to, because it's a completely new topic, generally speaking, with Python, and you can do statistical modeling and machine learning. So that's other topic. So over here, what we just going to do, we just going to get some glimpse of the modeling. Okay, so we are going to take a look some example. But there are two quite useful package. One is called the statistics models package. Okay. In this package, you can do some model like a linear model, and you can do some analysis at the meeting. Let me take, okay, so that one taken care of. Okay, so we are going to take a look some examples in this regarding. Let's see, keep having, hold on, I need to admit, okay. Say waiting room. Hold on, I needed to enable them. Admit, okay. Okay, so we are going to take a look example about linear regression. About the linear regression, okay, in the statistics model package. So that's one example we are going to take a look. And the general idea about linear regression is you're going to have like those like over here in this diagram, those red dots, those are the data points, is it? That point. And then you try to find some math equation, okay, to fit, we call it to fit the model, okay. So one way to do it in this case is, says you can do some linear regression. So basically it's kind of, you find a linear line, okay, and that linear line is the most approximate to this model. And for linear regression, if you want to use it to find this fit line, is we use a method, we call it OLS, so ordinary least square, to estimate, because linear equation, so in math, we know it can be represented as an intercept plus the slope, is it? And this X is the feature of your data. And so generally speaking, we call X as a feature. We keep having people coming in, okay. And so that's called a feature. And the Y part, we call it target. Okay, target. So so over here you have the intercept, you have the slope to try to find the best fit line, is it? And the way to find it here, it gives us, if you have a number of points. Is it like over here? You show a number of data points. Is it? So the way to find it is you need to find the mean of all of the data points, X and Y as features and their targets. Is it? Then you can plug in this formula. Then it will give you the intercept and the slope. Is it? And once you find that, that's going to be the best fit line. The best fit line, then when you have new data, suppose over here, is it? This new data, and you know it's a feature. So you only know, X, is it? Then with the X value, then based on this fitted line, you can find the predicted Y value. Okay, that's just a predict. Maybe the real Y value is over here, is it? But anyway, with this line, then you can predict if you know the feature. So that's the concept. We call it modeling. So over here, it gives us a brief idea about the linear regression modeling. And in our example later on, we are going to see how do we fit in this model, okay, and with some data. And there's some explanation about linear regression's result. Later on, we are also going to see. And you can also do multiple linear regression. Okay, you can have more than one features. So in the previous, it's just single feature, is it? So over here, you have more than one features. And then with this case, then we can do multiple linear regression. Okay, but linear regression is just one way to find. There are a lot of other ways. And so later on, we are going to take a look at our example, okay, in coding. And then the other one, the other model, we are also going to take a quick look. That's so the other one quite popular is sklearn package, okay, and it's from the scikit-learn package. And with this sklearn is most used for machine learning. So this is most for machine learning, okay, but some, like the linear regression, it's also included, okay. So later on, we are also going to see our examples. So that's the general idea about modeling. So next, let's take a look at our examples. I first need to find the example. Is this one? Okay, that's that one. So first, let's go over our first example about modeling. Okay, so how do we do the modeling? Okay, so over here, let's start. So over here, so this part is quite simpler, as we already know. So we generate a data frame, okay? And over here, we have X0, X1, and Y1. So the data looks like this, the data frame. And over here, later on, we are going to see it's kind of, we have the target. Generally speaking, Y is the target. You have single column of target, is it? And you may have more than one features, okay? So that's regarding this part, nothing new. And in pandas, we also learned, is it? You can also specify name for your column, is it? So over here, we also add a name for the column. So nothing new here. And then next, let's see. And over here, it says interfacing between pandas and the model code, okay? So over here, what we defines here is you also give the name, is it, for the features x0 and x1, is it? And generally speaking, when we do modeling, that's one key point is modeling only deals with numeric data. Okay, but previously when we learned for the data frame, it can also have non-numeric data. Is it like a string? Is it or other object? Is it? But whenever we want to do, no matter it's statistics modeling or machine learning, all of the data got to be numeric data. Is it? So today we are also going to see some way in case we have the data, non-numeric data, then we need to do some conversion, okay? So over here anyway, for this one, we also add the column x0, x1, is it? And we got all of their values. And then we add a new category, okay, a new column for that data frame. So this new data frame column, the data type is a categorical type, is it? It's AB type, is it? A category says it's AB. So if you take a look, you will find you have this is non-numeric. The non-numeric, it's a categorical data, okay? But when we want to do modeling, they are not going to be allowed. So you cannot directly use this data frame for your modeling. So before that, you need to do some conversion work, okay? One way to replace with category in pandas, there is a very useful function called get dummies. This function is going to be very useful, okay, get dummies. And get dummies, and then over here, what you specify which column you want to apply, okay, for this get dummy. And also for the new column, it's created what's going to be the name. So in this case, it's a prefix for the name. And then after we call the get dummies, is it what we get? If you take a look, you will see it has this two new column. It's called category underscore A, categories underscore B, is it? And AB, where does it come from? It comes from your original data, is it? Original data, is it? But that original data A and B, and they are category, is it? They are category data, is it? And over here, after I call the get dummy, that column is gone, is it? Replace with those two columns, I have two new columns called with the prefix category, is it? And then with what? Then the A and the B, it's coming from your original data, is it? So, but you have two new columns. And if you take a close look of the data, you will see, is it in the previously, the last row, it's B, is it? It's B, and if we take a look at our last row, you will find corresponding to B column, it's 1. Corresponding to A column, it's 0. So that means, okay, the last row is B, is it? And if you take a look at the previous, the fourth row, the fourth row, it's A. And then if we check the two new columns, then category A is 1, but category B is 0, is it? So yeah, so we have, so what this get dummy did is, it's kind of convert your non-numeric data, is it, with some new columns. That new column, what it's going to have, it's only going to have 1 or 0, is it? But that 1 or 0 based on your original column, if that category value is A or B. If it is A, then on your column category A, it will have 1. And if it is B, then under your new column category B, then it will be 1. Okay, so the new column the new column, all we have is going to be have 1 or 0, but they are numeric data. Is it because we needed to use numeric data to do our modeling, okay? And for the patency part, because it's rarely used over here, so we are going to skip that, okay? So then next, let's take a look the linear model part. Yeah, so we are going to start with our status model, okay? So in Python, how are we going to use it? I need to manage the participants. Okay, I think there's a new participant want to join in. So we start with a status model, okay? To start with, to do the status model, what over here we did is, then you needed to import the status model. And all of this, they are considered as API, if you take a look. API, okay, and you need, if we want to use, then you need to use the import the status model, okay, or status formula model. And then let's take a look next what we did here, okay. So what we did over here is we have this example. We define a function. So what this function is called dnorm, okay, and it has 3 parameters called mean, variance, and the size. And what's next is going to check is it's going to check if the size is an integer, is it? And if it is integer, and then it's going to return some number. Okay, so that's what this function does. And so the purpose of this is to generate some numbers that's around the mean and with a certain variance, okay? But here, be careful is over here, we need to be careful is we have a comma ended. Size equals to size comma, is it? And over here, later on, we did the star and the size. Then basically, if we take a look at the result, we will see if I plugged in, with 0 as the mean, and 1 as the variance, and 3 is the size, is it? And what I get, is going to be this. I have 3 values returned, is it? That's because over here you said, okay, you're going to plug in with 3, is it? And over here it's unpack, is it? It's unpack. And that's why you have 3 values generated, okay? And like over here it shows, is it? It says also over here, the random with numpy's random function generate. If you do first, so random, so this function, so it can have n1 like n2, is it plus? So this means the dimension, is it? So in this regard, it's the first dimension, is it how many numbers, random numbers you want to generate, is it? So over here, because the first dimension I'm going to specify, I need 3 numbers generated, so that's a random number generated. And because of this, so apply the size and you unzip it, so that's why you generate, you will have these 3 numbers. So that's what this part means, okay? And we understand that. And then what's next it's going to do is over here. So over here, then we also specify, over here you can see, we also specify the beta. What is beta? Is it? So beta over here is also 3 numbers, is it? And we also have an epsilon defined. And that epsilon defined, we call that denom function, is it? And plug in with the n. And over here, we are going to have 100 of the data be generated. And this y equation, basically in this case, it looks kind of like this. So you have three features, is it x1, x2, and x3, and plus the interceptor parts, okay? So that's the general model for this case, is it? And what here we try to show is how do we use a statistical model, is it? And then for our statistical model over here, we have that, we import that statistical model, is it? And then we say, oh, okay, we add a constant and we plug in with that x that we just generated, is it? And what it looks like, it kind of looks like this, is it? And with this, then you can plug in with the linear regression. So over here, we want to apply that linear regression model, is it? A linear regression with what? With ordinary least square, okay, way of the linear regression. And this is of the x values that we just generated, is it? And with the y features. So over here, you plug in with the data of x and y, okay? And the model we pick is a linear regression model, okay? After that, then you can call, okay, I'm going to fit my model. So I'm going to train the model, is it? Using the data that I provided. And after that, it will give you the parameters, because you try to, our goal, this is our goal, is it? We want to find an equation. In this case, we only know x1, x2, and x3. So we know a bunch of those values and its corresponding y values, is it? And you want to find out what b1, b2, b3, and epsilon are, is it? So those, the goal is to find those, to find the best fit values. That's our goal. Okay, and with that, we provide of x and y value, and we pick linear regression, is it? So I say, oh, I'm going to pick some linear representation, is it? Try to fit of the data, is it? And this linear equation is defined by alpha plus the beta x. Is it defined by its slope and its intercept? Is it? So then after you call the fit, is it? It's going to give you this line, is it? And this line, then the alpha and the beta, those value, is it? But in this case, not a single beta, it's at beta 1, beta 2, beta 3, is it? So over here, we find all this beta 1, beta 2, and beta 3, is it? So once you find, then basically you have the original model you want to find. It's beta 1, x1, plus beta 2, x2, plus beta 3, x3, is it? Plus some epsilon. Is it? That's the model you try to find, is it? So after fitting, you do find the model, okay? And with this, then whenever you have new x1, x2, x3 value, then you can predict its y values, okay? So that's the concept. And with the statistical model, the nice thing is you can call it a summary. Okay, and what the summary is going to give you over here is that it's going to print out a model detail diagnosis output, okay, of the model, okay. So if we take a close look, it will tell you, okay, your dependent variable, is it? It's y. And what model you use, is it? You use linear regression with least square. And what else it show totally how many data you applied, Is it over here? It's number of that we have 100 data set. Is it? And the degree of freedom. So here we have x1, x2, x3. So that's why we have 3 as a degree of freedom of our model. Is it? And the residual degrees of model, degree of freedom is going to be 97. Is it? And it also tells you what? Tell you R square value. Is it? R square value. It also tells us about some other remaining information that's also useful for statistic. And if you take a look over here, the furthermore, is it tell you we have the degree of model, it's 3, x1, x2, x3, is it? We have those 3 features, and their coefficient is going to be provided by these values, is it? And it also gives you the standard arrows, and also provide the p-value, is it? And based on the p-value, normally p-value can tell you how good your model is it? So if the p-value is less than 0.005, it's a pretty good model, is it? And here it also gives you the confidence, certain percentage of confidence level, okay? And in this regard, it's 2.5 to 97.5%. So this is regarding the percentage confidence level. So with the statistical model, and we can see what is the nice thing is it gives you a pretty comprehensive summary of the statistical model that you pick. Okay, so this is a nice thing for it. And then next, let's see. Over here, what's next is going to do. Okay, and for the statistical model over here, it also shows, is it? So we have the data frame provided, and you specify the values, is it? And then you can apply with the linear regression. So here we just discuss the simplest case, linear regression as a model. And over here, is it? You can provide the data, is it? And you can also kind of pick, okay, the columns, is it? Of your x values, basically corresponding to. And then you just call the fit model. And if you want, you can provide, it can provide you output about the intercept and the corresponding coefficient of this model, okay? And with this, basically, you get your model and you can proceed. And then over here, basically, it also shows, is it? Over here, then later on, after you have the model, then you can call the predict function. And over here, it's just a try, is it? And you use the first 6 data to do predict. So what this gives you is the y value, but this y value is a predicted y value. Predicted y, not the real value, is it? And then you can use it to compare what your original y value is it? To see how precise it is. But we can see over here, it's it has the offset, is it? Okay, so that's the first example is regarding linear regression uses statistical model. And what next over here shows is we can also use the machine learning model provided by the scikit-learn package. Okay, so over here, this we already quite familiar, is it? And reading CSV file and you load the data frame. So over here we have 2 data frame, is it? Because we have training data and we also have testing data. So we have our training data and the testing data, okay? And here just a glimpse of our of our data. And generally speaking, when we did the machine learning model, is it? And over here, we can also see is that some of the models you also have, like in this case, is it? It's non-numeric. Is it? All of this are non-numeric data. Is it? And another case is when we do machine learning, a lot of time with the null data, is it? So we will also want to check. So over here it says you want to find out, are there any null data and how many of the null data regarding each specific column it is it? So in this case, it says, oh, like age, it has quite a number of null data, is it? And the cabin, it has quite a number of the null data. And then how we need to deal with the null data when we want to train, okay, for the machine learning model. So over here, what we do is we try to fill those null data using media data to do the filling. Okay, so for our train data, the age, and the testing, the age column, we are going to fill the null data with what? With the median value to fill it. Okay, so that's one case to solve the media data. And to solve the null data case. And what next to try to show is, if you recall, you remember for the male or female for that column, is it? The data is also non-numeric, is it? So we want to change them to numeric data, is it? So over here, you can do something like this, is it? If it's female, then it's true or false, is it? So then it will convert it to either 1 or 0, is it? And after that, then you can get it. So after we perform our cleaning of the data, so we call those previous steps with the cleaning of data, is it? If you take a look, the data all change to numeric data, okay? And after that, with the numeric data, then we can start our training. In this case, so we are going to use logistic regression, okay? And the logistic regression, it can be used to do what? To do classification in machine learning, okay? And in machine learning, the classification is what? Is you have a lot of features in this case. Is it like X1? Those are considered as features. Okay, and here is your target value, is it? But target value, and here we are normal, generally speaking, we do binary classification. Okay, so it's, suppose it's a certain class, is it? So is it this class 1? Is it? If it is, you say, oh, it's 1. Otherwise, it's 0. It's not a class 1. Is it? If it is class 1 or if it's not class 1, and based on all of these features, is it? Based on these features, you have training data. Okay, training data is all of the data you collected, and you already know of those data's class, it's 1 or 0, based on all of the provided data. And we also have testing data. And with the training data, you're going to use a certain model to train. Okay, train and find the way to do the logistic regressions classification. Okay, and after you get to the logistic regression, so then later on with the testing data of the provided X values, then it can use a model to predict it's 1 or it's 0. And because it's testing data 1 and 0, they also provide it, and you can use them to check how accurate your model is. Okay, so that's the general idea about machine learning's logistic regression. And with machine learning's logistic regression, we can see it's quite simple to use if we direct borrow from the library. So you first need to set up this variable, whatever variable you want. Is over here we call it model. Okay, you said I'm going to create a logistic regression instance. Okay, an object. So after you create this object, on this object, you're going to apply your data. Okay, so this is your training data set. So training data set. So you apply the training data set and you just call the fit function. So then internally it's going to train the model, okay, train the model. And regarding logistic regression, it's not a linear regression, okay. Linear regression is used to, so linear regression, is it? It's used to predict the model. So it's used to predict Y values based on the known X value. That's the point of linear regression. And with logistic regression, logistic regression is used for classification. So the general look, it looks something like this. So here you have 0.5, and here you have 1, is it? And then you're going to have some curve, looks like this. Okay, we call it a sigmoid curve, okay? So for logistic regression is the probability of certain data belongs to class 1 or class 0. So if it is that class or not, okay? So if the probability greater than 0.5, then you say, okay, that model is the class. So it's class 1. Otherwise, if it's less than 0.5, then it's going to be class 0. Okay, so logistic regression, it gives you the probability about the certain data belong to a certain class. So we needed to use the train data, okay, to train our logistic model, okay, to find how you, based on what kind of probability, then you can classify it. After that, you get the model trained, and then you can just call predict with whatever the X value you have, then you can get the prediction model. So in this case, it's try to predict with X test data, is it? So that's its classification result, is it? Classification result, you have the predicted one. And over here it shows you can also check with your train model, is it how precise it is. So with the after you train a model with of the X train value, if you call the predict, it will give you the corresponding predicted Y value, but with train data, is it? And after that, over here it also shows, and we can also collect the corresponding parameters regarding the model. Okay, so over here, if you take a look, is it can find you see your predicted model. This is regarding a predicted, and this is the real training of the Y, is it? So the offset will give you how accurate it is it? And of course, the fewer So the fewer the value of this, that means your model is kind of better, is it? But that's just regarding the train part. Okay, and with the logistic regression, you can also collect some other information. Okay, like over here, you can also collect the intercept, the coefficient, and the mean square error of those values. And generally, what we interested is about the accuracy. So the data score will give you how accurate. So how accurate your model is. So model's accuracy. Okay, and then in this case, if you plug in with the train model, is it with of your train, then it will give you the accuracy. So in this case, the accuracy is around 79%. So it's not that a fantastic model, is it? And but anyway, to give you the accuracy, is it about 79% of this logistic regression. And over here, it also shows, so this is your train one, is it? And this is your train data, this is your predicted data, is it? And if you do this kind of check, and if you can find the mean, it also give you kind of the accuracy, is it? So over here, using this, you can also find. But with sklearn, with this sklearn, normally you can just call the score and it will give you the accuracy, okay, so that you don't need to recalculate, apply certain formula to recalculate. And the next is shows this also logistic regression, but this logistic regression, what it's cross validation. So the cross validation is going to better train off the model, okay? Better train off the model. So the basic idea is, the basic idea for the cross validation is you have a big set of data. So generally in machine learning, for the data, you just split it into two parts, the train parts and the testing part. Okay, and your fit, you call fit with the train, is that with the train? And then generally speaking, we find the accuracy with the testing part, okay? But if you just do this kind of simple split, it's not enough. So generally, what we said is you can do the cross validation. Cross validation then is, this is regarding your train part, is it? And within your train, you further divide into, we call it number of folds. So n folds. Okay, n folds, then you have certain number, we call it a k number of repetitively do training and validation. So the case is you may get the first n-1 folds, you set them for train. And leave the last one, we call it validation. Okay, and then you keep repeating this. Then you pick the n-2 plus this previous one, you use it for validation. So you have all of my shaded part, then as a train, and pick this one as your validation. So you keep kind of rotate, cycling of the n folds doing this. So instead of just train and test, you have train, you have validation, and then you also have testing. Okay, so that's this, what this model does. The logistic regression with cross validation. Okay, here it specify I wanted to have 10 folds, is it? And in this case, why we do this is because after this, it can improve your models accuracy, your training models accuracy, because it not depends on the fixed set of the training model data, okay? And over here, it's a lot of time. You can also get your cross-validation score, is it in this case? In this case, the cross-validation score shows for the first, I'm sorry, previously I got the wrong information. Over here it said in this one, C is 10. That's, we don't need to worry, okay, it's kind of complicated, because in machine learning, this C is used for regularization. So that's for regularization parameter, okay. And it's mostly used to optimize learning weight. But that's some other topic, and it's too much at this point for us, okay. And in this case, we do the cross validation. The fold, we only have 4 folds. Okay, we only have 4 folds. So regional data is we have testing data, and we have training data. Among the training data, we divide into 4 folds. 4 folds, okay. 4 folds, then you can have the first 3 as training, and this last one as a validation. That's the first iteration, okay. The second iteration, then what we can do is, so this is testing, and we have 4 folds. Is it for the second iteration? Then you can pick this 3 shaded as training, and this is as validation. Okay, and then for the next one, for the next iteration, what it's going to do is, so this is testing, and we have 4 folds, is it? And then it's going to do is, it's going to have this 3 shaded as training, and this as validation. So it's keep doing until it gets all 4 folds. That's what the concept here it discussed, okay, the folds. And then the result, you can see here it gets the cross validation accuracy score, is it? And you can see it's improving, is it? It's improving the accuracy. So this is the basic idea about modeling, okay? So modeling, we just get a quick glimpse of our modeling, and we are not going to go to too much of it, because that's just completely two other big subject about modeling. So, but anyway, here we get some glimpse idea about all of the modeling. And so Wednesday, what we are going to do, we are going to starting our case study, okay? And with the case study, then you will understand how you have some big set of data, and how do we analysis it to achieve a certain goal. So that's a major information about today's class. And can we do this? And if we, just for CS433, okay, CS433, please just send a message in chat. You just send a message in chat, okay? And only for CS433, 603, we don't need to do that. So would you please, you just send a message, and oh, please put your name there. so that I needed to collect some, yeah, just whatever you say, you just type your name, okay, so that I will keep track of kind of the attendance, even though it's not mandatory, okay, but so all in CS3, if you are here today, can you just type your name there, okay, to the chat, so that I will be able to collect that. And that's all for today. So I will see you all on Wednesday. Only CS433, okay. If you're from 603, you don't. No, CS 603, you don't need to send me message. No other question, is it? Okay, so see you all. See you all Wednesday.
Sorry.
No, I send it. I should send it to everyone.
Should I send? For which class?
See you all Wednesday.
No, please. For which class should I send my name?
Oh yeah. Don't worry. It's only required for CS433. 603 you don't need to send. It's not mandatory. Okay, yeah. Okay. Just 433. Okay. So CS433. Please send your name. And otherwise, just see you all on Wednesday.
All right, thank you, Dr. Liu.
Yeah, see you.